Shri Gurubhyo Namaha children. Children, yesterday we discussed about unrestricted random sampling. Today we are going to discuss about restricted random sampling. Restricted random sampling is one which conditions or restrictions are attached during the process of selection. In unrestricted random sampling, we no need to follow any conditions or restrictions. But in a restricted random sampling, we have to follow certain conditions and restrictions during the process of selection. When instead of pick and choose method, in our previous method we discussed about draw of lots and about random number table we discussed. But here the sample is selected following a particular method. So the aim is to bring greater accuracy in results. So there are many restricted random sampling methods. The three most important sampling methods are stratified sampling, cluster sampling, and systematic sampling. First, we are going to discuss about stratified random sampling. In this sampling, the universe is subdivided into subgroups called strata. So the meaning of the word strata is groups. So in this method, we are going to subdivide the universe into groups, and a simple random sample is then taken from each stratum, that is from each group. So while doing this, we have to keep in our mind two things. First, there should be a great homogeneity as possible within each strata, that is within each group. And second one, there should be as marked a difference as possible between the strata. And in the simple form, the stratified random sampling means in this method, we are going to divide the entire universe into groups. So dividing into groups, that is called stratified sampling. In this picture also, we can see the sample is divided into various groups, that is group 1, group 2, group 3, group 4. Next one, ways of stratified random sampling. So in our illustration of a universe of 2000 students, the population consists of students from different classes, that is from 1 to 10, for example, if we take. So we can conveniently divide this universe into 10 groups. So first standard, all the first standard students into one group, and all the second standard students into another group. So like that we can keep on dividing them into groups. So after that process, once the universe is divided into strata, the next step is to select items for sampling from each strata. So there are two ways of doing this. One is proportionate sampling and another one is disproportionate sampling. So in proportionate sampling, we are going to take a fixed percentage of items from each strata. In disproportionate sampling, we are going to fix a number of items from each strata irrespective of the size of strata. For example, if there are 50 students in a group, already we divided the universe into group. If there are 50 students in one group, so we are going to fix a percentage. For example, we can fix 10% from each group. So out of 50, we are going to select 5 students. So in the same way, we can select 5 students from each group. So that is called proportionate sampling because we are fixing certain percentage. Next one is disproportionate sampling. Here we are going to fix a number. For example, if we decide to select 10 students from each group, then we are not going to bother about the strength of the class, whether that section may have 40 students or 50 students. But fixed number, we are going to select 10 students from each group. So that is called disproportionate sampling. So once the strata are determined, a random sample is drawn from each stratum in the same way as we followed in unrestricted random sampling. Now you must have understand the difference between the restricted random sampling and unrestricted random sampling. Now we are going to discuss about cluster sampling. So cluster sampling is similar to the stratified sampling, but there is a small difference in the method of grouping. So in cluster sampling, the universe is also divided into groups. Out of this, some are selected as sample sample groups called sample clusters. There we selected items from the groups, from the divided groups, but here we are going to select that group itself as one item. So sample groups, these sample groups are called sample clusters. The word cluster is also called group. So the meaning of the word cluster is also group. Suppose if we plan to divide the universe into 10 groups or clusters, two steps are taken to draw a sample. So first, out of the total number of clusters, some clusters are selected as sample clusters. Suppose two clusters are chosen as sample, then from each of the two selected sample cluster, a random sample of items is drawn. Now we are going to discuss about one example that is related to cluster sampling. Suppose if we decide to do a survey to examine the working conditions of workers in an industry which comprises of 100 factories. So there are all types of workers from lower level to the higher level. Since all factories belong to one industry, the type of workers employed by each factory may not differ. In this situation, instead of drawing samples from all factories, some of these factories may be selected as samples and then sample drawn from each factory. So the sample so drawn may be 100% or less depending on the requirements of the survey conducted. Cluster sampling is suitable when two conditions are fulfilled. First, there is a great heterogeneity as possible within a cluster. For example, within a factory, there is great heterogeneity as far as workers are concerned because the workers are of different types. Second, there should be as small a difference as possible between the clusters. For example, the different factories must be employing nearly the same types of workers because all these factories are producing same products, similar products are producing in all the factories. The third one is systematic random sampling. So in this, the first member of the sample is selected. We are going to fix the number, and then every nth unit we are going to include in the sample. So the word systematic, it stands for orderliness or order. So in this sampling, all the items in the universe are first ordered, and then every nth item is included in the sample, and we are going to select from that. So the ordering may be alphabetical or according to the admission number. So it is in our hands, it is in the hands of the investigator. For example, in our example of 2000 students may be ordered on the alphabetical order, or on the basis of their age, or on the basis of their parents' income, or any other basis. So after ordering is done, every 10th item may be chosen for selecting the sample. So in this method, we have to keep two things in our mind. First, there should be a similarity between the items which we are going to arrange in order. Second, the differences should be go on increasing between the neighbors. So for example, if there are 100 items to be ordered, the difference between item number 1 and item number 21 must be greater than the difference between items number 1 and item number 10. So and so on, the differences should be go on increasing order. So there should be increasing order in the differences. The systematic random sampling involves two steps. First step is to order items in universe. Second step, we are going to select every nth item. So in this stage, you should be familiar with two terms. So the two terms are sampling interval and sampling start. Sampling interval depends on the size of the sample. For example, if we have to survey 200 students out of universe, that is 2000 students, the size of the sampling interval would be 10. So it means we have to select every 10th item from the list. Once the size of sampling interval is determined, the range of choice for sampling start is also determined. The sampling start must be somewhere between 1 to 10. Suppose we select 5. Then we take items like 5th, 15th, 25th, and so on. If we select 9, then we take items like 9th, 19th, 29th, and so on. The sampling start is chosen on random basis. Either the statistician himself he can decide on what basis he is going to select, or he can take the help from two methods we discussed in unrestricted random sampling, that is draw from lots, or he can prepare random tables also, but the number should be from 1 to 10. Now next one, we are going to discuss about purposive sampling. Purposive sampling is totally different from random sampling. So purposive sampling is by choice, while random sampling is by chance. So in purposive sampling, the choice of the sample is left to the investigator or the sampler, the person who is going to investigate and select the item. So the statistician chooses the sample on the basis of characteristics under investigation. Suppose if we assign an investigator to study the fee structure of several schools. So there are hundreds of schools, isn't it? So Instead of choosing the sample on random basis, the selection of sample schools is left to the judgment of the investigator. So he or she, on the basis of the knowledge about schools, the person can choose a certain number of schools, and he should be confident that the schools which he is going to select should possess the characteristics of all the schools in that particular city. So that type of sampling is called purposive sampling. Okay, children, I hope you are clear with restricted sampling and unrestricted sampling and purposive sampling. In the next class, we will be discussing about sampling errors. Thank you, children.